about the mid segments, the lengths, lines, parallels, perpendiculars and intersections. So here we are going to discuss the midpoints of the two-dimensional objects. Now, for the properties of mid segments, the segments that join the midpoints of a pair of sides of a triangle is the parallel to the third side half as long as the third side. Like here you can see B is the midpoint of AC, E is the midpoint of AD and R is the midpoint of DC. So if we are connecting these points, then the same you can see the triangle formed here by connecting these points, and this length will be equal to this length and this length will be equal to this length. Also this length will be equal to this length and this length will be equal to this length. So this is very important property of the midline of the mid segments of the triangle. You can simply prove this by the previous theorems of similar triangles and the congruency of triangles. Now here you can see in the diagram R, S, TU are midpoints of sides of triangles XPO and triangle YPO. In triangle XPO, and triangle YPO, if OP is equal to 12, then RS is equal to what and TU is equal to what? If RS is equal to 8, then TU is equal to what? If RS is equal to 2x and OP is equal to 18, then x is equal to what and TU is equal to what? If OP is equal to 4x and RS is equal to 6x minus 8, then x is equal to what? Consider triangle XYZ with vertices x11, vertex y 5y, vertex z 39 and midpoint M on xz. So we have to complete the following by answering, and we have to give the solutions for all these fill in the blanks. So first of all, we have the diagram here, and the only given information is that RS to U are midpoints. RS TU are the midpoints, like T is the midpoint of OY, U is the midpoint of PY, S is the midpoint of XP and R is the midpoint of XO. When would you use the midpoints of a triangle when trying to determine the relationship within a triangle? When trying to solve for a variable or a length application problems, when needing to cut across the center and find the distance. Perpendicular bisectors in a triangle. This is called the perpendicular bisector of triangle, perpendicular bisector of the line segment AB, because this length and this length both are equal. This length and this length are equal, and this angle is equal to this angle, this angle is equal to this angle, because this is the perpendicular bisector of line segment AB. Construction of a perpendicular bisector. What do you notice about the perpendicular bisectors of the triangles? Lengths, lines, parallels, perpendiculars, intersections. On triangles 3 and 4 on your worksheet, create the perpendicular bisectors for the triangles. Circumcenter. The point of congruency of the three perpendicular bisectors of the sides of a triangle these points, this point will be equidistant from each vertex. Actually we are here finding the circumcenter of this triangle. So to find the circumcenter, we just have to take the point of intersection of perpendicular bisectors of the sides of these triangles. Like here, this is the perpendicular bisector of AC, this is the perpendicular bisector of AB, and this is the perpendicular bisector of BC. So this is the point of intersection of the perpendicular bisectors of the sides of this triangle. So this is called circumcenter of this triangle, mentioned by O. And one more interesting thing, that if we take this point as a center and take the compass on this second point, like on vertex B, A or C, anywhere, and if we rotate this by using the center, this point O, so it will form the triangle, it will form a circle passing through the vertex A, B and C. What will be the circumcenter look like in the following angles? Acute, right, obtuse. How do you know? Do these findings make sense? You have to think and solve this answer, solve this question.